non-homogeneous linear differential equation of second order, LDE, means linear differential equation of second order, second and higher order, second and higher order, second and higher order, second and higher, with constant coefficients, with constant coefficients. With constant coefficients. With constant coefficients. COE, FFI, CI. Constant coefficients. Concepts. Concepts. Consider the nth order. Consider the nth order linear. The nth order. Nth order. Nth order. Nth order. Nth order. Non-homogeneous differential equation. Non-homogeneous. Homo means homogeneous. No, non-homogeneous differential equation. DE means differential equation with constant coefficients. With the constant coefficients. With the constant coefficients. Constant coefficients. With constant coefficients. L of y equal to L of y equal to an d power n y by dx power n plus an minus 1 an minus 1 d power n minus 1 y divided by dx power n minus 1 plus so on a1 dy by dx plus a naught y that equal to q of x that is equation number 1. Equation number 1. Equation number 1. So where page number 205. All of you follow that page number 205. Your textbook. Where A1, A2, etc. An are constants. With condition An is not equal to 0. if y of is the if y of c is the solution of the solution solution of the underlying homogeneous equation of the underlying homogeneous equation. Homogeneous equation. Homogeneous equation. So L of y equal to L of y equal to an e power 1 y by dx power n plus so on a1 dy by dx dx plus a naught y equal to 0. Equation number 2. Consider equation number 2 called complementary function and y of is here. Y of c is called complementary function. Complementary function. Complementary function. Y of c, y of p is called particular integration. Particular integration. Integration. Total general solution. Hence, GS means general solution of equation number 1 is y equal to y of c. Y of c means what? Complementary function. Y of p means what? Particular integration. This is the general solution. Complementary function plus general solution. So the operators D inverse the properties of polynomial operator. Let D denotes D denotes the derivative d by dx. Now similarly d square by dx square. So on denotes d square d cube etc. d power n. Right. Here the index d power n indicate the index d power n indicate the operator of indicate that the operation of differential must be carried out n times. Means differentiation, nothing but n times differentiation. N times differentiation. N times differentiation. Here D inverse stands for, here D inverse is nothing but 1 by D. Stands for for integration operator. For integration operator. Integration operator. Right. Integration operator. So for example, d of sin x is there. Sin x, d by dx of sin x is cos x. Right. Huh? So d inverse of sin x. D inverse of sin x is there. This is nothing but integration. Integration of sin x is minus cos x. Right. Similarly like that. Next. Page number 208. Page number 208. Page number 208. No? Non-homogeneous equations of higher order. Higher order. Determination of particular integrals and the general solutions. Type 1. Type Suppose Q of x has the form, let Q of x of the form, Q of x of the form, Q of x of Vx power k, Vx power k. PD of y equal to PD of y equal to Vx power k. To find yp, now put to find yp. Yp means what? Particular integration. Now put P of d in the form. Put P of d. Now put P of d in the form. P of d in the form. In the form. A naught d power r 1 minus f of d 1 minus f of d by taking out the lowest degree form, by taking out the lowest degree form, lowest degree form. Say A naught d power r. Say A naught d power r It's d power from P of D, from P of D, P of D. Then y of P equal to y of P equal to y of P means what? Pi. Pi is nothing but particular integration, that equal to 1 by P of D, 1 by P of D to Bx power k, right? That equal to what is the P of D here? P of D is nothing but A naught d power r, A naught d power r 1 minus f of d, f of d 1 minus f of d bx power k, bx power k, right? Page number 208, all of you students model b of k. Okay. That equal to 1 by A naught d power r, A naught d power r. Here, denominator is there now, we have to keep it in the numerator, that is 1 minus f of d whole power minus 1 into b of x power k, b of x power k. So, for instant, if p of d equal to d minus, if p of d equal to p of d equal to d minus a naught, d minus a naught, where a naught is not equal to 0, then particular integration y of p means particular integration 1 by p of d by p of d b x power k, b x power k, x power k, that equal to 1 by d minus a naught, d minus a naught b of x power k, not x power k, that equal to 1 by 1 by 1 by minus a naught, minus a naught. We are taking common from this one, minus a naught means 1 minus d by a naught. B of x power k is as it is, x power k, right? That equal to minus 1 by a naught, minus 1 by a naught, 1 by a naught, minus 1 by a naught. This can be written. You take it on the denominator is then I have to keep in the numerator. Then this becomes 1 by d by a naught whole power minus 1 into bx power k as this. Hence, that equal to minus 1 by a naught. So expand this with using binomial theorem. What is the binomial theorem? 1 minus x whole power minus 1. That can be written 1 plus x square, x square x square, so on. So this we can write 1 plus d by a naught means x d by a naught, b by a naught plus 1 by a naught square by a naught square d square a naught bx power k. So where a naught not equal to r, not equal to r. A naught is not equal to r means r is not, and a naught is not equal to 0, not r. If printing mistake is there, you have to correct and understand. A naught is not equal to r. Not equal to. When k equal to 0, when k equal to 0, this leads y of p equal to, this leads y of p equal to minus b by a naught, So we shall work out the problem to now illustrated method. Okay, this is the concept. Now we'll do example, page number 209. Page number 209. Page number 209. Example sum. That is 10.3.1. Okay. D square y by dx square. Solve the equation. Solve the equation. D square y by dx square. D square y by dx square plus dy by dx by dx plus dy by dx plus y that equal to x square Solution. The auxiliary equation of the given equation. Auxiliary AU x I L I A R Y. Auxiliary equation of I am putting for abbreviated form. AE. AE means consider in future auxiliary equation is m square plus m plus 1 equal to 0. How it is in the form of quadratic equation. So you have to split the middle term or using formula. What is that formula? X equal to minus b plus or minus. Here x means m minus b plus or minus. Consider x equal to minus b plus or minus under root of b square minus 4ac. B square minus 4ac whole divided by 2a. This formula will use as roots are m equal to minus 1 plus or minus root 3i whole divided by 2. So we need to write first complementary function. So then CF is nothing but complementary function. That is nothing but y of c that equal to e power minus x by 2 e power minus x by 2. X by 2 from where we got? Here, minus 1 by 2 plus or minus root 3 by 2 I. If you divide this minus minus 1 by 2 into x minus x by 2, that equal to, because imaginary roots. So solution must be C1 cos root 3 by 2 cos root 3 by 2 plus C2 sin root 3 by 2 sin root 3 by 2, right? No, sin root 3 by 2. Root 3 by 2. The differential equation can be put in the form. The differential equation means DE means differential equation can be put in the form. Put in the form. Put in the form. In the form. In the form. D square means operator form. D square plus D plus 1 to Y to Y. That equal to x square equal to x square. Where? Here, where P of D, where P of D equal to, D square plus D plus 1. D square plus D plus 1. So here particular integration. PI means particular integration. That we are denoting by shortcut form y of p. That equal to 1 by P of D by P of D x square. That equal to, what is P of D? P of D is nothing but D square plus D plus 1. I will write opposite. 1 plus D plus D square into x square. This can be written as P of D, 1 plus D plus D square whole power minus 1 power minus 1. Not this power, whole power. That means whole to the power of minus 1. To the power of minus 1 into x square. That equal to this we can expand 1 minus D plus D square. D plus D square. Plus D plus D square whole square plus 1 into x square that equal to into x square that equal to, here 1 into means x square. Differentiation of this is nothing but like that. D plus D square into x square plus D plus D square whole square into x square plus 1 that equal to x square. Differentiation of x square is 2x. 2x differentiation is 2. 2x differentiation is 2 plus x square plus 2 plus 2 since d power k of x square equal to 0, because for k is greater than or equal to k is greater than or equal to 3. K is greater than or equal to 3. So y of p equal to x square plus 2 minus 2 get cancelled. X square minus 2x square minus 2. So general solution. What is general solution? Y equal to complementary function plus particular equation. What is the complementary function here? E power minus x by 2 into C1 cos root 3 by 2 plus C2 cos root 3 by 2 into plus x square minus 3x x square minus 2x minus 2x. This is the solution. Right. Page number 210. Page number 210. Page number 210. Type 2. Type 2. Type 2. Consider these are all important for 10 marks. Consider P of D y P of D y equal to P of e power ax. P of e power ax. The particular integration Pi particular integration y of p that equal to y of p equal to 1 by p of d. 1 by p of d. 1 by p of d. B e power ax. B e power ax. Case 1. Case 1. Case 1. So if p of a is not equal to 0, if p of a is not equal to 0, p of a is not equal to 0, then y of p equal to, then y of p means particular integration equal to 1 by p of a, 1 by p of a, 1 by p of a, b e power ax, b e power ax. We have p of d, we have p of d, we have p of d, b e power ax, e power ax, e power ax, b e power ax p of a, b e power ax p of a, yeah, by exponential property, by exponential property, exponential property, by exponential 1 by p of d, then 1 by p of d, 1 by p of d into p of d into P of D. B e power ax. B e power ax, that equal to B e power ax. B e power ax. P of a. P of a. P of a. Then y of p equal to, y of p equal to 1 by P of D, 1 by P of D. Page number 210. Page number 210. 1 by P of D. B e power ax, that equal to B e power ax whole divided by, in place of D we are substituting a, P of a. So this is considered equation number 5. Equation number 5. Okay, equation number 1 consider. Equation number 1. Case 2. Case 2. Case 2. If P of A equal to 0, if P of A equal to 0, P of A equal to 0, then D minus A is a factor of P of D. Then D minus A is factor of D minus A is factor of P of D. P of D. D minus A is a factor of P of D. Let D minus A whole power R. Let D minus A whole power R be the highest factor of P of D. Be the highest factor of highest factor of P of D. Highest factor of P of D. So P of D equal to D minus A whole power R. D minus A whole power R. D minus A whole power R. P1D. P1D. Where P1A is not equal to 0. Where P1A is not equal to 0. P1A is not equal to 0. So y of P equal to 1 by P of D. B e power ax. B e power ax. B e power ax. That equals to 1 by D minus A. 1 divided by D minus A. 1 divided by D minus A. P1D. B e power ax. B e power ax. By equation number 1. Right. So 1 by D minus A, that equal to 1 divided by D minus A whole power R. D minus A whole power R. 1 by P1D. D. B e power ax. B e power ax. B e power ax. That equal to 1 by d minus a by d minus a. Page number 211. 211. D minus a whole power r whole power r. B e power ax whole divided by p1a p1a. Equation number 2 consider. Right. By exponential shift property. By exponential. By exponential shift property. Shift property. Exponential shift property. D minus a whole power r minus a whole power r into e power ax f of x or ax f of x, that equal to e power ax d power r into f of x to f of x, right? So in particular f of x equal to in particular f of x equal to d power minus r into b we get d minus a whole power r into e power ax e power ax d power minus r into b, that equal to e power ax d power r and d power r into d power minus r of b, that equal to b e power ax So therefore 1 by d minus a whole power r 1 by d minus a whole power r b e power ax that equal to e power ax d power minus r of b equal to e power ax into b e power ax into b e power ax into b d power minus r whole power 1, that equal to b e power ax into x power r divided by r factorial Exclamatory mark means r factorial. Consider. This is equation number 3. Equation number 3. Now, from 1, 2 and 3, from equation number 2 and 3, we obtain means we get y of a particular integration equal to 1 by p1a into b e power ax into x power r ax whole divided by b e power ax into x power r divided by r factorial that equal to b e power ax into x power r divided by r factorial into p1a r factorial into p1a. Okay, using this concept, we'll solve one example. That is page number 211. Page number 211. 211. That is example 10.3.4. 10.3.4. So solve means solve the differential equation. D square y by dx square. D square y by dx square. D square y by dx square plus y that equal to 3 into e power minus 2x. 3 into e power minus 2x. Okay, solution. First, auxiliary equation of the given equation. AE, previously we discussed auxiliary equation AE means auxiliary equation of given differential equation is m square plus 1 equal to 0. That implies m equal to the quadratic equation. This is use formula. What is that formula? X equal to minus b plus r minus under root of b square minus 4ac whole divided by 2. That equal to plus or minus I. Plus or minus I. I means iota. Plus or minus iota. Read as iota. Hence, y of c means complementary function equal to c1 cos x, because this is also a imaginary iota, c2 sin x, c2 sin x. This is the complementary function. Then to find particular integration, find pi means particular integration y of p equal to we write operator form. What is that operator form? B square plus 1 into y equal to 3 into e power minus 2x. In place of a, minus 2 is there. That's all. So particular integration y of p equal to 1 by d square plus 1. 1 by d square plus 1, d square plus 1 by d square, 3 e power 2x. 3 e power minus 2x, minus 2x, that equal to 3. 3 is constant, we are taking outside. 1 divided by by concept, we need to substitute e power x coefficient. X coefficient is minus 2. In place of d, we are substituting minus 2 whole square plus 1. E power into e power minus 2x. Okay, that simplified form is 3 by 5 e power minus 2x, e power minus 2x, e power minus 2x. Right. So general solution. So we need to general solution. What is general solution? Y equal to complementary function, means y of c means complementary function. So particular integration, y of p is the particular integration, that equal to c1 cos x plus c2 sin x, 1 cos x plus c2 sin x plus 3 by 5 e power minus 2x, 3 by 4, that is the solution. So next type 3. So we don't have time, that's why I need to page number. Most important for 10 marks questions. One also VP method, variation of parameter method also is there, that is compulsory question on 10 marks. So page number 213, 213, type 3, type 3, do it as homework. And one example sum using this concept, page number 113, page number 213, example, easy means example, 10.3.9, 10.3.9, do it as homework, important for 10. Next, page number 215, 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 215, type 4, type 4, do it as homework, most important for 10 marks. Using this concept, one problem, this is also most important for 10 marks question. Example 10.3.12, 10.3.12, homework. right? Next. Page number 219. Page number 219. Page number 219. Variation of parameters method. 10.4. 10.4. Variation of variation of parameters. Parameters method. Variation of parameters. This short form VPM we can say. VPM. Variation of parameter method. Concept to do it as homework. Read first concept. Then using this concept, page number 221. Page number 221. Page number 221. 221. Example sum. Example sum. 10.4.2. 10.4.2. Most important for 10 marks question. Theory. 10 marks question. Okay, students. Okay. Do you have any doubts? If you have any doubts, please ask me. Right? Okay. I'm leaving. Okay, tomorrow we'll meet at 12 p.m. Okay. Thank you.
Thank you, sir.